So what we have here, right, we refer to these as compound angles. Compound angles. Now, the idea with compound angles is that they allow us to either go from something that looks like this to something that looks like this, or vice versa. So if we're given something like this, we can expand it into something like this if it's going to help us to break down the expression or simplify or do whatever it is that we would be required. You see, and these are other variations. There's sine with something plus something, and then the sine with something minus something. You see, same goes for the cos. There's cos with something plus something, and then there's cos with something minus something. You see? Yeah. So these compound angles, right? We basically use them when we need to solve identities. So when I say we basically need them when we need to solve identities, I mean just that. See, when solving identities, we need to use these different kinds of compound angles depending on what the question looks like. So what we have in addition to compound angles is double angles. We're just going to mention double angles for now, and then we'll go back to compound angles and try and say a bit more. So with double angles, right, it's also something else on your formula sheet. So it's not like you have to cram them. You just have to know that they are there, and you need to be able to identify when to use them and how to use them. So for example, as you can see here, you see there's cos with 2 multiplied by an angle. That's why it's called double angle. You see 2 times an angle, and then here with sine, 2 times an angle. That's why it's called double angle. You see, double angles over here, double angles over there. So the idea is, whatever this looks like, right, it can be written as one of these three. So the main one is actually this one up here. You see, cos 2 alpha is equal to cos squared alpha minus sine squared alpha. You see, this looks a lot like the square identity, but it just has a minus in the middle, and then cos starts. You see, you cannot swap these around like you can swap the square identity. So just a reminder, right, the square identity is this one. Let me put here square identity so that we're on the same page. The square identity is the one that says sine squared alpha plus cos squared alpha plus 1. This looks familiar, right?
It does.
Yeah. So let's see here. So with that being said, right, remember this can be swapped around. It will still make sense. If the cos comes first and the sine comes after, it doesn't matter. Just like our 1 plus 2 is the same as 2 plus 1. But what we know about this expression is that the cos can go to the other side. And then you have sine squared alpha equal to 1 minus cos squared alpha. You see? And then another variation is if the sine is the one that goes over to the other side. Cos squared alpha minus 1. No, cos squared alpha is equal to 1 minus sine squared alpha. You see, these are two variations of
the same thing.
Yeah, two variations of the same thing. You see, there's sine squared alpha here, cos squared alpha there. You see, all coming from this main one. So with double angles, right, it's almost a similar scenario, because all that happens is that with these double angles, right, they may seem as though it's three, different things, but it's actually just one main thing, and then these two just come from you changing this into something specific for one scenario, and then for another scenario you'll be changing the sine squared alpha. So what I mean is, you see, remember cos squared alpha can be written as this, and then sine squared alpha can be written as this. Do you see that?
I see it.
Yeah. So all that they do to get these two here is that you see where the cos squared alpha is here. They just replace it with 1 minus sine squared alpha, you see. So for the other one, where you see this cos squared alpha, they replace it with 1 minus sine squared alpha, right? That's what they replaced this one
Yes.
with. And then here they just still have it, minus sine squared alpha. Let me actually maybe put it in green so that it's the one that's originally there. See? So once they've done that, that's how you end up with 1 minus 2 sine squared alpha. That's why you see these are like terms. Minus 1 gives you minus 2. You see, that's how they end up with this one, this variation over here. You see that?
Yeah, I see it. But even, oh, okay.
Yeah, it's only because they changed the cost. For the other one, instead of changing the cost, they change the sign instead. So when they change the sign, they change it based on this one. You see, the sine squared alpha can be written as this 1 minus cos squared alpha. So what that does is if you change this to 1 minus cos squared alpha, what that means is you'll also have, you see here the cos squared, remember it's staying the same. But then if you change the sine squared, you see you'll have a minus here. In brackets, you can drop in there 1 minus cos squared alpha. So if you do that, 1 minus cos squared alpha. This is going to give you cos squared alpha. Multiply it inside, you have minus 1. Multiply inside, you have plus cos squared alpha. You see? And then cos squared plus cos squared, that's a 2. Because it's 2 of the same thing, right? Minus 1 here. You see it?
Yes, I see it.
Yeah. So all I was trying to say is that this is the main one. These are just extras. More like, not to say they're extras, but I'm just going to say that it's not that they are just random things that they just threw there. Obviously there's long proofs to show why this is correct, but you don't have to worry about that. I was just showing you that what you have down here and what you have down there, it's all because of things like the square identity. It's also to show you that with trigonometry, everything just works together. Everything just works together, and that's how you break down identities. You will be making use of a lot of things at your disposal. You'll be making use of compound angles, making use of double angles, you'll be making use of the square identity, and you'll be also making use of the tan ratio. See, tan, a value is equal to sine over cos. You see, and if
Okay.
it's swapped, if it's 1 over 10, meaning this has been flipped over, right? If it's 1 over 10, then this will also be flipped over. It will be cos over sine. You see?
Jeez, 10 is just everywhere.
Yeah, 10 is just everywhere. But all this is more like a summary of the grade 12 specifics that you GR12 formulas. Now let's just say
Okay.
grade 12 identity new formulas. You see, these are on the formula sheet. So it's not a matter of cramming them. You need to know they are there. Then we obviously need to know when to use them, which is what we're going to do just now. Cool.
Beans.